Compound interest is a little bit more complicated than simple interest, but in this case, it is when interest is left in an account and also earns interest. Let's say interest over interest. For example, a woman deposits 100,000 in a savings account that pays 6% interest, compounded annually. Find please the balance in her account at the end of each of the first 3 years. So this is what we do. Year 1, we multiply 6% times 10,000, and that's 600. So the balance is 10,000 plus 600. So we have 10,600. In the next year, that'll be year 2. Again, 6% times 10,600. In this case, we multiply by the previous amount and not the original amount. So we get 636. Please notice how the interest amount is growing from 600 to 636. And so, it's growing and it's adding the original amount, the original interest amount. So that'll be, in this case, in this year, 636. So the balance is 10,600 plus 636. So that's 11,236. In the next year, that'll be year number 3, we multiply 0.06, that's 6%, by 11,236. That's 674.16. So the final balance would be 11,910.16. So you can see from this information that the formula could be the following. So we have the original amount, that's 10,000, plus 600, and that's 10,600. So 10,000 is A0, 600 A0 times R, because that's the original amount or the capital multiplied by the interest rate. So that's A0R, and that's what we or what the person will have at the end of the year. So that'll be A1. That's the first year. With this in mind, we can continue and find the formula. So in the first year, we have the amount at the end of the year, that'll be A0 plus A0 times R. We factor out A0, so we get 1 plus R. And that's like the formula for the first year. In the next year, we have A2 is equal to A1 plus A1 times R. Again, we factor out A1, and we're gonna have A2 is equal to A1 times 1 plus R. So that's the formula for the second year. We substitute the value of A1 into this formula, and we know that A1 is equal to A0 plus A0R. So that's A0 times 1 plus R times what we had left, and that's 1 plus R. So we can sum this up, these two terms, 1 plus R, 1 plus R, and we get 1 plus R to the square times A0. And from the classes and from what we did before, you can see that this amount is growing. So in year number 2, we have 2. In year number 3, we have 3. In year number 4, we have 4. In year number 50, we would have 50, and so on. So the formula for the compound interest is A n is equal to a0 times 1 plus r to the n. So this is the formula we're going to use for the compound interest. And actually, as you will see later, this is the formula for the future value. Okay? Why? Because we are finding the value of something or of some amount in the future, in 1 year, in 2 months, in 3 days, in 5 months, etc. Okay? So this is the formula as well for the future value. So let's see some examples. A. For their newborn child, parents deposit 10,000 in a savings account that pays 8% interest, compounded annually. How much will there be in the account on the child's 20th birthday? Okay, we use the formula. It's a simple calculation. The original amount or capital is 20,000. The interest rate, okay, in this case we're using I, is equal to 8% or 0.08. The period is 20 because it is asking for 20 years. So we substitute these values into the formula and we get 10,000 times 1 plus 0.08 to the 20th. So we get 46,609.571. Okay, so that's the amount that they'll have in 20 years. Okay, next, if those parents invested the money in an account paying 8% compounded quarterly, how much would they have after 20 years? So instead of compounding yearly, we're gonna compound the interest rate quarterly. Okay, in this case we need to get first the periodic rate. So that's I is equal to R over K. R is the interest rate. That's the interest rate. K is the period. So we expressed this amount in the following way. So 0.08 over 4, because the year has 4 quarters. So you divide 12 over 3, and that's 4. Okay. So the value that we get is 0.02 or 2%. Okay, we substitute these values into the formula and we get 10,000 times 1 plus 0.02 to the 4 times 20. Why? Because we are expressing the time and the periods in the correct way. We get this amount, that's 48,754.40. So the formula we're using when we have a different compounding is AN is equal to A0 times 1 plus I to the K times N. And I is equal to R over K. This is what you have to do when you're using a different compounding, instead of using like a yearly or annually compounding. So if you're using like monthly, bi-monthly, or daily, or any other different compounding, then you need to use this formula. So whenever you're using yearly or annual, yearly or annual compounding, please use this formula. Okay, finally, Liz needs 5,000 for gasoline because now gas is very expensive in Mexico. If she gets the money from a bank and the bank writes a 10% 180-day note with interest compounded daily, what will she owe at the end of 180 days? So here you have to pay attention to these details. 180-day note, okay? Interest compounded daily. And she's gonna pay in like 6 months. So that's 180 days. That's half a year. Because for financial purposes, the year has 360 days instead of 364 or 365. Okay, first we get the periodic rate. So that's I is equal to 0.10 over 360, and that's this amount. Okay, it's like a little bit bigger than the previous amount. The initial amount or capital is 5,000. The interest rate we know is 10%, so that's why we get 10 over 360, because we want to get the daily rate, because the problem is asking for the daily compounding. Okay, K is 360. We're using days, and N 180 days, so that's half a year. We use the formula that we have, that's AN is equal to A0 times 1 plus I to the K times N, and we plug in the numbers, so that's 5,000 times 1 plus this rate that we calculated before to the 360 times 0.5, because we have, because the problem is asking for half a year. Okay, once we make the calculations, we get 5,256.53. So in this example, you need to pay attention to the compounding that the problem is asking for. In this case, it is daily compounding, and pay attention to the days or the periods the problem is asking you to include in the problem.